Welcome back, everybody. In this video, what I want to do is say a few more things about translating negations and then do a proof here about some stuff with negations too. So here, I'm going to call these, just for the sake of convenience, F1 and F2. By that, I just mean the first formula and the second formula. There's nothing magical going on there. Here's two statements. And I'm going to say, imagine here that D stands for President Trump is a Democrat, and R stands for, and I'll go for that, President Trump is a Democrat, I'll abbreviate, and R stands for President Trump is a Republican. Now, actually, predicate logic would be more helpful to get the clarity of those statements down, but we're not going to do that in this course, at least at this point. So if those things were true, D stands for President Trump is a Democrat, and R stands for President Trump is a Republican, the question I have for you right now is, are these two statements equivalent? If I say something like this, President Trump is not a Democrat and President Trump is not a Republican, that's how we read that one, and I say this one, President Trump is not both a Democrat and Republican, are those statements equivalent? They are not. The first one is saying he's not a Democrat and he's not a Republican. That means he could be something else. He could be a libertarian, he could be a communist, he could be a socialist, he could be what have you, okay? This is simply saying he's not this one and he's not this one. The implication is he could be something else. This one is saying he's not a Democrat, he's not both a Democrat and a Republican. That is to say, he cannot be both a Democrat and a Republican at the same time. In fact, in the case of President Trump, he has been a Democrat, he is currently a Republican, but he can't be both at the same time. This is saying simply that. You can't be both of these things. Can you be both at the same time? No, you cannot. This statement, on the other hand, is saying he's not this and he's not that, so they're not equivalent. Now, another way of saying this expression, like when you see a dot or a conjunction with a not in front of it, you're saying those two things cannot go together. Not both of this. Another way of saying it, in this case I would italicize the entire phrase, it's impossible for these two things to go together. So let's take a look at this one. I want you to solve for this here. We're going to do a little proof with reference to this translation. This would say, based on the translation criteria I've given you, if President Trump is a Democrat, then he's not a Republican. Prove then that he can't be both at the same time. He can't be both a Democrat and Republican. So here's what we'll do. We'll stick this up here as our assumption, and I'm going to say, prove this. Can we do an arrow out? Nope. Modus tollens? Nope. And out? Nope. And in? Nope. Is our goal an arrow? Nope. What are we left with? Indirect proof. Our goal is not DNR, so what we're going to do is provision assume the opposite of that. Or be just regular old D and R as a provisional assumption for an indirect proof. Arrow out? Nope. And out? Yep. Now again, there's actually two routes you could go here. You could go arrow out, or you could do modus tollens. I've said to you before, go ahead, I don't have it on the board anymore, go ahead and do things in this order. That will always get you, or I'll say at least 95% of the time, it will always get you the most efficient results. So can we do an arrow out? We totally should, yeah we can. Right there. That gets us not R. Arrow out, 1 and 3. Okay? Now remember, in an indirect proof, you're trying to get two contraries and stick them together. Do we have two opposites that we can stick together? Right there. So we put them together, R and not R. That's an and in, 4 and 5. We did it. We provisionally assumed the opposite of our goal. We got a contradiction, which means we have proven indirectly that if we say as an assumption that if President Trump is a Democrat, he is not a Republican, then we can say confidently, well, that means he can't be both those things. How? Indirect proof. From where we started the provisional assumption in line 2 to where we got the contradiction in line 6. Okay? Next video, I'm going to move on from talking about this stuff to talking about biconditionals and their various rules.